Welcome to this video on P4. This is the hardest questions in the last 3 exam sessions. And this is based on not my opinion, but that of the examiner, the chief examiner's report. In that report, it does state which questions the majority of students had issues with. And what I've done here is collate those questions together, and I'm going to go through them. So let's get started. Now, this question has quite a bit of information to do with the shape and so on, but we've got a graph for that shape, and that graph you can see is rotated through 360 degrees. Now, this means it's going to be an integration question. And this is not given to you in the formula booklet, so you do need to remember it. So we're looking at, when we integrate, it's going to be pi multiplied by, and this is the integral of y squared dx. So that is something that we do need to be aware of. Now, what we've got to do here is we've got to take this one, square it, and then integrate it. So let's go for it. We've got pi on the outside. May take something else at the moment. We've got between 0 and 4 for my limits. Y squared, so we've got 1/4 4 minus x e to the x, and this is going to be squared. Now obviously you could work out the squared part first and then substitute it in. So 1/16, 4 minus x squared e to the 2x. And in fact what I think I will do is I'll just do the expansion on the side. So 4 minus x squared is 16 minus 8x plus x squared. And of course, all of this is going to be multiplied by that 1/16 and e to the 2x. But what I think we will do is, let's take the pi and the 16 outside for the 1/16. And then we have 16 minus 8x squared plus, minus 8x, isn't it? Plus x squared multiplied by e to the 2x. My apologies. I hadn't fully read the question there. Seems that we actually stop at this point. So v equals pi by 16 integral between 4 and 0, and it's x squared minus 8x plus 16 multiplied by e to the 2x dx. Pop those dx's in there, which was here. Where k is the constant to be found, so k is just this pi by 16, isn't it? Now for part B, we need to finish this off and actually integrate it. Now this is obviously integrating by parts here. So u equals x squared minus 8x plus 16, and dv by dx equals e to the 2x. So we want to integrate this one, so we get e to the 2x divided by 2, because we'll divide by this differentiated, and we need to differentiate this one. That gives me 2x minus 8. Now we just need to substitute this into the formula. This formula is in the formula booklet, okay, in the integration section of P4. U dv by dx is equal to uv, so my volume is equal to, now we've got this pi by 16, haven't we, coming out from it. So I'm just going to pop that in brackets, and then it's u times v. So x squared minus 8x plus 16 times e to the 2x over 2 minus. And then we need to integrate v du by dx. So that is integrating 2x minus 8 times e to the 2x all over 2. And if you look in here, again, we've got a product, so we're going to have to integrate by parts a second time. So I'm just going to make a little bit more room on my page. So we still have our pi by 16. We still have this x squared minus 8x plus 16 e to the 2x over 2 minus, now I'm going to have another set of brackets as I'm going to have to integrate this. So I'll do this, let's pop up in red. Now we're going to take again a u, which will be 2x minus 8, and the v by dx, which will be the e to the 2x over 2. Now normally I do this bit in my head, but obviously I'm just do it here for you so you can see. So that's what we're doing. So we've got u times v, so 2x minus 8 multiplied by e to the 2x over 4 minus the integral of, and this time it is v du by dx. So we've got now the integral of this times this, which is a little bit nicer. So this is just going to be e to the 2x over 2 now. But what I might actually do, let me put it in just in case anyone's watching this and then suddenly gets a bit confused. So let's put it in, so it's 2 times e to the 2x over 4. There we are. And as I'd already said, this will cancel with this, giving me a squared term. So we get pi by 16, x squared minus 8x plus 16 times e to the 2x over 2 minus 2x minus 8 times e to the 2x over 4 plus, and it's plus minus times that, and minus times this minus is going to give me my plus, because I'm getting rid of this bracket. Integrating this, e to the 2x over 2 is e to the 2x over 4. So it's e to the 2x over 4. And all of this is between 4 and 0. So pi by 16. Now, substituting in 4, this is going to give this bracket as 0. And then substituting in 4 to here, 2 4s are 8, 8 minus 8. That's going to put this bracket as 0 as well. And then substituting 4 into the end, we get e to the 8x. Sorry, when we're talking about it's no x, is a e to the power 8 over 4. And of course we are subtracting, so I can keep it like this separate, or what we could do is just pop it all together in this case. So that is when I substitute in the 4. Let's substitute in the 0. So that's 0, 0, 16. So 16 times e to the 2x over 2. So that's going to be e, my apologies. So e to the 0, isn't it? That's just going to be 1. So we get 16 times 1 over 2. So that's going to be 8. Minus. And then 2 zeros is 0. So we get minus 8 times 1/4. And don't forget about this minus. So it's going to be positive 2. Substituting into the end, 0, so this is going to be 1/4, and it's positive. So we're now looking at pi by 16, e to the 8 over 4, and then we've got a constant and raised. So this is 10 plus 1/4, which gives me 41/4. Now it does tell me that it wants it in this form. Just make that larger so you can see. So the form doesn't have any fractions in it in the front. Okay, it does say simplified. So let's take the over 4 out. So 4 times 16 there is 64. So we can say that this is pi by 64 e to the 8 minus 41 centimeters cubed. We probably could have got away with as it was, but I think this is just a much nicer end to it by taking the 4 out since it's in both of them. A very time-consuming question with that kind of by parts twice, but by parts twice is something that's quite common. Used to come up in the old C4 and the C34 papers, and again, you know, it is starting to show itself in these P4 papers. So do make sure that you are aware of it and that you know you have practiced a few where you do have to do that integration a second time. So this first one is the same as if, say, this was x equals and we're doing a dx by dy. All we're doing is differentiating it. So if I've got my 1 over 1 plus 2 ln y squared, then what I want to do is move this onto the top. So that's the same as then this being to the minus 2. And I'm differentiating it, so d this by dy. Now we need to multiply by minus 2. 1 plus 2 ln y. Take 1 away from the power. And then I want to multiply by the inside of this bracket differentiated. So 1 is obviously going to just differentiate to nothing. 2 ln y is going to become 2 over y. So that gives me on the top minus 4 and 1 plus 2 ln y cubed multiplied by y. And that's on my bottom. Now for part B, what we need to do is first rearrange this. So if I get my y's onto the left, so that gives me 1 over y 1 plus 2 ln y cubed dy. And on the right, we get 1 over 3 cosec 2x dx. And of course, then we are integrating. Now, looking at this left-hand side first, you can see it's very much like this. It's just this minus 4 as a factor, isn't it? So if I think about taking, say, minus, you know, I want this to be a minus 4. So if I take a minus 1/4 out, and then I can put minus 4 in here, y 1 plus 2 ln y cubed dy. Does that make sense? So now this is exactly the same as this. Times the top by minus 4, so I also divided by minus 4, which is the quarter. I'm just going to pop an equals there, and I'm just going to finish this left-hand side off because it's going to be this now. So it's going to give me 1 over 1 plus 2 ln y squared. Now, looking at the right-hand side, I can take the 1 over 3 out, just to make my life a little bit easier. 1 over cosec is going to be sine 2x dx. And then sine differentiates to cos, so it integrates to negative cos. So we're going to get minus 1/3 cos 2x. And when I integrate, I need to divide by this differentiated. So I'm also then going to be multiplying by a half, and plus a c, a constant. So on this side we got minus 1/6 cos 2x, and on the left side we got 1 plus 2 ln y squared on the bottom of my fraction. And some of you might have noticed that I made a slight mistake. There's minus 1/4 here. I obviously forgot it coming into this one, so I'll just add it in there. And this is why it's also worth just looking at what you've done. You know, I did this bit and then I just obviously realised I just missed out that minus 1/4. So here we've got the answer, pretty much. It doesn't tell me how to set it out, so, you know, I can mess around with these numbers. I could multiply by 4, I could multiply by, you know, this 6, and I certainly could deal with the negative numbers. There's a -1 here and a -1 here. But and I could have put the plus c on this side. So there are a few different options, but I've done this and I'm going to leave it like this because it doesn't tell me a form to have it in. So what I don't want to do is make a silly mistake as I try and make this a little bit nicer. And part C tells me that y equals 1 when x equals pi by 6. So let's substitute these values in. So you get minus 1 over 4 times 1 plus 2 ln 1 squared, and that equals minus 1/6 cos pi by 3, because it's 2 times pi by 6, plus c. Now, ln 1 is 0, so that's 0. 1 squared is just 1, so that's a 4. So we just get minus 1/4 there. Pi by 3, cos of pi by 3 is a half. Minus a 6 times a half is minus a 12 plus c. So adding a 12th, we can see that c equals minus 1/6. So at this point, I should really put this back into the original. So we get our value of c here. Like so. But now we need to get it in this form, isn't it? So this is now all about a bit of manipulation. So just follow my steps here. So I'm going to just multiply by 6 first of all. Like so. And that's going to give me minus cos 2x minus 1. And I'm going to swap these sides, so I get cos 2x plus 1 equals 6 over 4 is 3 over 2, isn't it? So 3 over 2, 1 plus 2 ln y squared. Now what I want to do is I want to multiply by this bracket, but divide by this. So again, I'm going to do that in one step. So it's going to give me 1 plus 2 ln y squared equals 3 over 2 cos 2x plus 1. Next, I just realized that the sec is just a single x. So let's think about the cos 2x. So cos 2x is 2 cos squared x minus 1, isn't it? So actually I can replace that with this. So I've got 3 over 2, and it's going to be 2 cos squared x minus 1, and of course we still got the plus 1. So I've only replaced this with this, and that is still there. So that's going to go, isn't it? So that's going to give me 3 over 4 cos squared x. Oh, now it looks like we're starting to get somewhere. So the cos squared x can obviously go to the top and become a sec squared. And we can also do a square root. Let's square root first, shall we? So So we have 1 plus 2 ln y equals root 3 over 2 cos x, which is 1 plus 2 ln y is root 3 over 2 sec x. 2 ln y is root 3 over 2 sec x minus 1. And then I'm going to divide by 2, so ln y is root 3 over 2 sec x minus a half. And looks like we're almost there. Sec x minus half, and that a is in front. And apologies, this one should be over 4, shouldn't it? Because I've divided by 2. Now I just need to rewrite this. So it's going to come y equals e to the root 3 over 4 sec x minus 1 half. And there we have it, where a is root 3 over 4. Not a very nice question, and one that's going to take a bit of time there. 5 marks? Yeah, I mean, unless you're well practiced, it's probably going to take you more than 5 minutes. But it is a bit of manipulation, and I think the trick, like I almost missed it, but a single angle in here, that was one of the key moments as I went through it. Now, according to the examiner's report, this is a question where many candidates had no idea of how or where to begin, which is why we're going to go through it now. What I'd say is just a little diagram, not that it really makes any difference in this, but we're going to get some sort of random L, or R, which is this 4, 2, minus 3, plus lambda, minus 4, minus 3, 5. Okay, and then there's a point A, which will be, say, just somewhere randomly. Let's put it out here, because it's all in 3D, isn't it? So it's not as easy to kind of draw. So there's A, and then X is the point on L, which is the line I drew first, nearest A. So if it's nearest A, what that actually means is it's going to be at perpendicular or right angles. So this is what we're thinking of. So think of the right angles here. This is going to be my X. Now, if they're at right angles to each other, then remember that A dot B is equal to 0. And for us to do that, we need to think about the two lines. So we know this line, but this one we're a little bit less sure of, because we can't just use this, because that would be A to the origin. We don't know if this line goes to the origin, but we know it's A to X. So that's what we want to find, the line AX. And AX is going to be X minus A. If you remember, I'll just do it very, very briefly up here. If I have a vector, say OA, position vector, and position vector OB, then this vector AB is going to be minus OA, because we're going this way, plus OB. So it's going to be OB minus OA. And this is very much the same from A to X. It's going to be OX minus OA. That's what I'm looking at. Yeah? So, you know, the origin is obviously off there somewhere, but OX minus OA. Now, OX would be this, with the value lambda that we need to know. So that's going to be 4 minus 4 lambda, 2 minus 3 lambda, minus 3 plus 5 lambda, minus 9 minus 3, 2. So that's going to give me, if I take away 9, minus 5 minus 4 lambda, and minus 3, so I'm adding 3, we get 5 minus 3 lambda, minus 5 plus 5 lambda. Now we can go ahead and use our A dot B. So our A is like our AX, is this minus 5 minus 4 lambda, 5 minus 3 lambda, and minus 5 plus 5 lambda. And then for B, we want the directional part of this equation. That's what gives it its direction. So we want minus 4, minus 3, and 5, and make that equal to 0. So now we just need to do our multiplying. So minus 4 times minus 5 and minus 4 lambda. So we're going to get 20 plus 16 lambda. And then we're going to get minus 15 plus 9 lambda, minus 25 plus 25 lambda equals 0. So in terms of my lambda, we got 25, 9, and 16. Gives me 50 lambda. And looking at our numbers here, it's going to give me minus 20. So 50 lambda equals 20, lambda equals 20 over 50, or 2/5. Now that doesn't mean we're finished. I'm just going to move this up, because what we need to do now is substitute lambda back into our original equation for R, wasn't it? So we had 4 minus 4 lambda, 2 minus 3 lambda, and minus 3 plus 5 lambda. Substituting my value of lambda in here will give me my coordinates of x. So, 4 minus, and we've got 8/5, 2 minus 6/5, and minus 3 plus 2. And that's going to be x. So the coordinates of x are 12 over 5, 4 over 5, and minus 1. And that just takes us up to this point. Now we need to find the shortest distance from A to L. We know the coordinates of x, we know the coordinates of A, because the position vector. So that means that we can find this distance. So that's going to be the modulus of AX. So square root, and you just want to find the difference in each value, the x direction, the y direction, the z direction, squared. So we're going to use this as well. So we've got 9 minus 12/5 squared plus minus 3 minus 4/5 squared plus 2 minus 1 squared. And that gives me the square root of 67, which is where I leave it. So that wasn't too bad. So part 1 obviously worth most of the marks there. Part 2 just probably worth 2 of these marks for such a short bit. Now, second part here, we've got the point B is the image of A after reflection in L. So if I go back to my original kind of sketch, just as a rough idea, we had my line L, we had then a value for, A, and I did a little kind of dashed line on it, didn't I? We had an A, and that was our X. So something along those lines. So if we reflect in L, then our B should be further along this line and the same distance away from X, wouldn't it? So like AX will be the same as XB. So what's the vector AX? Well, it kind of comes from this bit up here, doesn't it? I never actually worked that bit out. But ax is x minus a, isn't it? So it's actually 12 over 5 minus 9, so minus 33 over 5i. And then we've got 4/5 minus minus 3. So it's going to be 19 over 5j. And then we've got minus 1 minus 2, so minus 3k. So what we've done is the x minus the a to get the ax vector. All I need to do now is apply the same kind of thing from x to get to b. Okay, it's that same kind of distance. So ax is equal to x b. So that means that xb should be minus 21 over 5i plus 23 over 5j minus 4k. And that is then the position vector of b. So I'm just adding that distance onto this, and that will take me here. So a to x we worked out, so x to b then is just x plus that ax distance. Now, if I look at this one, we've got obviously our shape, which is going to play a part of this, and then within here we've got some rates. So we've got here constant rate of 0.6 pi meters cubed per minute. So this is got to be a dv by dt, isn't it? And then if I look further down, when we start this actual question, this is the same, dv by dt. Okay, but this is a rate leaving. So I can quite comfortably say that dv by dt is going to be my 0.6 pi minus 0.15 pi h times that height. So that's my dv by dt. Now we obviously got to get to a dh by dt. We've already got the dt. We need to get rid of a dv and gain a dh. So we are obviously going to be looking for a dh by dt. That's what we're looking for, because we're looking for a dh by dv, because dh by dt is going to be dv by dt times dh by dv. That would mean these would cancel, leaving me my dh by dt. That is the scenario we're trying to get to. So we need something in terms of volume and height. And here we have it. It's a cylinder. So formula for volume of a cylinder is pi r squared h, isn't it? We know that the radius of this shape is 4. So 4 squared is 16, so 16 pi h is what my v is. And if I differentiate this, I get dv by dh is 16 pi. Now I've got everything I need. dh by dt is dv by dt, which is my 0.6 pi minus 0.15 pi h. And my dh by dv is this inverse, isn't it? So it's times 1 over 16 pi. Now the pi's will cancel because there's pi on each of the terms on the top and on the bottom. So that makes it a little bit easier. And then, we've got these kind of fractions, haven't we, that we need to deal with. But let's first just make it a little bit nicer. We got 0.6 minus 0.15h over 16. And looking at what we are doing, or what we need here, to get my 320, I'm going to multiply top and bottom by 20. So that should give me 12 minus 3h over 320. And that was what we were needing. Okay, hopefully followed through with that okay, and I think a quite straightforward initial 4 marks. So for part B, we've got our dH by dt. Just going to write that out again. And what we really need to do here is we want to find the height, don't we? And it's all to do with height and time. Height is obviously the depth in this case. So what I really want to do is I want to be a bit of rearranging and then differentiating. Oh, sorry, integrating, isn't it? So if I multiply, let's keep the 320 there and multiply by dt to keep it on the top. We've got the dh there. We need the term with h in it. So we need to divide by that. So it's going to be 1 over 12 minus 3h. And we are integrating. So this first one is going to be ln 12 minus 3h. Not quite just that, but what I'm actually going to do is I'm just going to do this on the side in a different color. I've talked about kind of this kind of method before, where I do a rough integration and then I differentiate and see. So it's 1 over 12 minus 3h times minus 3. Okay, so you can see I'm going to end up with that factor of minus 3 here. So I need to divide by minus 3. So this is going to be minus 1/3. And then my next one, well, this is just a number times by t from the dt. So I'm going to get t over 320 plus a constant. Now, it tells me that it was 0.5 meters when the tap is opened. So the tap is opened at t equals 0, and there the height was 0.5. This will enable me to find my value of c. So substituting in, we get minus 1/3 ln 12 minus that 3 over 2 equals 0 plus c. So c equals minus 1/3 ln 21 over 2. So now I can say my equation is minus 1/3 ln 12 minus 3h equals t over 320 minus 1/3 ln 21 over 2. So this now is my solution to my actual equation. And now what I've got to do is find the time taken step. So there we are, h is 3.5 and we want to find t. So it's just substitution, isn't it? So 12 minus 3 lots of 3.5 equals t over 320. And we got minus 1/3 ln 21 over 2. So that gives me minus 1/3 ln 3 over 2 plus 1/3 ln 21 over 2 equals t over 320. And rearranging here gives me 207.5637 and so on. Doesn't tell me what to round to, so it should be 3 significant figures. And of course it's minutes, as that is what was in the question. Now, this is only a 2-mark question, and these proof questions have definitely got better over time in terms of how people have answered them. But when they first showed up, Generally, people either didn't answer them, especially since they're 2 marks, or couldn't answer them. Okay? So prove by contradiction. And the funniest thing about this question is that it is example 1 of your textbook, if you have the Edexcel textbook for P4. So, so easy. So assumption is where we want to start. And that's going to be the opposite. So there is a greatest odd integer. And you need to call it something. For example, n. Another option would be, say, 2n plus 1, which is what I usually prefer to go with. It's totally up to you. Okay? And then we go with, well, n plus 2 is also an integer. And n plus 2 is greater than n. N plus 2 is an odd plus even, therefore it is odd. And then we just finish with a simple statement, a conclusion, if you will. So something along the lines of, so there exists an odd integer greater than n. And this contradicts. Sorry, my spelling here is terrible, and it's like in the question as well. The assumption that the greatest odd integer is n. Therefore, there is no greatest odd integer. Job done. Now, there were quite a lot of mistakes in this question. Candidates found it particularly difficult. They had some success for a few marks, but there were so many errors in here in total that I thought we should go through this question. Now, we've been given the substitution for u. So let's go straight in with what we're doing. I'm going to call this I. We're given u, and u is 3 plus root 2x minus 1, isn't it? Now, I know that my 2x values are 13 and 1. So let's also find the u values for that. So that would mean if I substitute 13 into here, I've got 2 13s are 26, minus 1 is 25, square root of 25 is 5, 3 plus 5 is 8. And for the second one, 2 times 1 is 2, 2 minus 1 is 1, 1 squared is 1, 3 plus 1 is 4. So now I've got 8 and 4 as my 2 limits. Lovely. Now, I can substitute in for this, so we've got 4 over, and that is the same as that, so it's 4 over u. But I need to deal with this dx. So let's differentiate this. So u equals 3 plus, and I'm just going to first write this as a power. And then du by dx is, the 3 is going to go, we're going to get half 2x minus 1 to the minus a half. And then this one needs to also multiply by the inside differentiated, which is multiplied by 2. So the 2.5 obviously cancel, leave me 1 over 2x to the minus 1 and the square root of that. Now, if I look back into the original bit for u and rearrange, you can see that root 2x minus 1 is going to be equal to u minus 3. So we got that to swap in, and sorry, this is still du by dx, isn't it? So du is going to be equal to 1 over u minus 3 dx. So what I've done here is I've multiplied by dx, and I swapped this with the u minus 3. Then this I need to multiply up. So this dx equals u minus 3 du. And that then gets substituted in over here in replace of this dx. So this is u minus 3 du. Now I need to go ahead and do a bit of simplifying. So 4 over u times u is just 4. And 4 over u times minus 3 is minus 12 over u, and this is du. Goes between 8 and 4. Now, integrating the 4 is going to become 4u minus 12 ln u between 8 and 4. So 4 times 8 is 1632 minus 12 ln 8 minus 16 minus 12 ln 4. Now, 32 minus 16 is obviously 16, minus 12 ln, and I'm going to swap the 8 for 2 cubed, because in the question it's ln 2, but also this is 8, this is 4, they both come from 2, so it makes sense. So this is going to be plus, because it's minus and a minus, and we get 12 ln 2 squared. So 16 minus 36 ln 2 plus 24 ln 2, 16 minus 12 ln 2. And this is now also in the form we wanted it. So we've got integration by parts here for part A. So if we're integrating e to the 2x sine x dx, then in this case it really doesn't matter which one I call u and which one I call dv by dx, because they're both pretty much as easy as the other one, really. So, if I do it this way, when I find v, I get e to the 2x over 2, and du by dx is cos x. And if I did it the other way round, I'd end up with a minus sign and a multiple 2 times. But it should always work out in the end. So this is going to be uv. So we got e to the 2x over 2 sine x minus, and it's v du by dx, so e to the 2x over 2 cos x dx. That's not very nice, is it? Because that's essentially very much like what we started with. So it's a little bit confusing, but let's keep going first. Now, if I'm integrating this one, I'm just going to put this into a squared bracket. So it's going to be, I'm going to use the same kind of process again. So I'll pop it in red just over on the side, out to the way. So we've got u as being cos x and dv by dx. I'm going to use this the e to the 2x over 2 again. So du by dx is minus sine x, and v is going to be e to the 2x over 4. So that will give me uv is e to the 2x over 4 cos x minus integral e to the 2x over 4 multiplied by minus sine x dx. And just squeeze that in there. So let's get rid of our bracket. So we get e to the 2x over 2 sine x minus e to the 2x over 4 cos x plus, no, hang on, apologies. So this minus and this minus is going to make it a plus, but then this minus will make it a negative. So minus e to the 2x over 4 sine x dx. And then I've got rid of my brackets. But you can see now it looks like we're going to have to go through this again, doesn't it? But we don't. Now I'm just making a little bit more room here so we can see. So what I'm actually going to do here is, if you remember, I is the integral, isn't it? So that is the integral of e to the 2x sine x dx. I think like algebra, I've got that both sides. In fact, this is just 1/4 of it. So what I could do is I could take that quarter out. So if I just redo this one and take the quarter out, it looks like this, doesn't it? Now add that quarter, a quarter of that to this side, and what I get is 5 over 4 integral e to the 2x sine x dx equals e to the 2x sine x, and that one's over 2, and e to the 2x cos x, and this one's over 4. And then what I want to do is I want to multiply by 4 times by 5, because I want to get rid of this fraction. And again, I'm just going to move it up a little bit. So we get integral e to the 2x sine x dx. So I'm timesing by 4, dividing by 5. Timesing by 4, dividing by 5. And that is what we end up with. And technically we've got a plus c because we don't have any values on here, do we? There's no limits. If you haven't seen one of these type of integrals before, then you will look like, or you will believe that you're going around in circles, and that's why it's really useful to see it now in this video. Now for part B, we first need to find our limits. So looking at our equation, we want to make y equals to 0 to see what these 2 points are. Well, this is obviously 0, but this one we want to find. So e to the 2x sine x. Now, e to the 2x can never be 0. So what we can say is sine x equals 0. So sine x is going to be 0 at 0. And then the next time it's going to be at 0 is 180 degrees or pi radians. So that will be my two limits here. So what I'm looking at is I'm integrating between pi and 0 e to the 2x sine x dx, which obviously we have already integrated. And just paste it in from before. So that's what we have. And all we want to do is we want to get rid of our plus c, put a set of brackets around it, and pi and 0, and then substitute in. So sorry about that. So it's just 2/5 e to the 2 pi sine pi minus 1/5 e to the 2 pi cos pi. And that then we're going to take away the same thing but with 0 in it, which I will really try and squeeze in because I haven't left myself much room here. Yeah, no good, I had to move it across. Minus 1/5 e to the 0 cos of 0. So what that does is that gives me, well, we know sine of pi is 0, so that's going to go. So we got minus 1/5, so cos of pi is going to be minus 1, so that's going to give me a positive 1/5 e to the 2 pi. Then looking in the second one, sine of 0 is 0, so again that'll go. And then this one we've got cos of 0 is 1, so we get minus 1/5 there, but it's a minus here, so we get plus 1/5, because obviously e to the 0 is 1, isn't it? So plus 1/5. So this gives me then e to the 2 pi plus 1 over 5 to put it in the form that they want. Now, with this one, where people tended to go wrong, or candidates went wrong, is with this, skew. Very few seem to know what it meant. And what it means is this. It means that the lines do not intersect and are not parallel. Obviously, if you think on 2D, lines are parallel, they don't intersect. And if the lines aren't parallel on 2D, they do intersect. However, when we go to three-dimensional lines, there's this scenario where these two lines do not intersect and are not parallel to each other. And that's what this meaning of skew is. So when we come to work on these, we need to essentially prove that 1, they are not parallel, and 2, they do not intersect. So let's write these equations out and make them equal, assume as if they are going to intersect. So at minus 1 plus 2 lambda, minus 1 lambda, 4 plus 5 lambda there. And that equals 2 plus 4 mu. Then we got minus 2 minus 3 mu minus 5 plus b mu. So let's start with the top one. We got minus 1 plus 2 lambda equals 2 plus 4 mu. And 5 minus lambda equals minus 2 minus 3 mu. So these two equations is what we're going to start with, but I'm just going to write down the third one. Like so. So, dealing with 1 and 2 first. And basically, I like to use elimination, so I'm going to times this one by 2, which is going to be 10 minus 2 lambda equals minus 4 minus 6 mu. And I'm going to use then equation 1, which is my minus 1 plus 2 lambda equals 2 plus 4 mu. And of course, I'm going to add these. So we get 9. These two values will obviously disappear, eliminate from each other. 2 plus negative 4 is minus 2, and 4 plus my negative 6 is minus 2 mu. So this is minus 2 mu equals 11, or mu equals minus 11 over 2. And now I need to stick with 1 or 2 and substitute this back in. Now I'm going to use equation 2 as it's got 4 times it, and that'll help eliminate that fraction. So sub in, sorry, equation 1, isn't it? Yeah. sub in 1 minus 1 plus 2 lambda equals 2 plus 4 lots of minus 11 over 2. Minus 1, well actually we can take this minus 1 to the other side, can't we? So let's do that. 2 lambda equals 3, and then we got 4 times 11 divided by 2, so 4 divided by 2 is 2, so minus 22 there. So 2 lambda equals minus 19, lambda equals minus 19 over 2. So now I've found my mu and my lambda. And at this point you've earned half your marks, you've earned 3 marks. So from 3, now we've got the 4 plus 5, lambda is minus 19 over 2, isn't it? Equals minus 5 plus b lots of minus 11 over 2. And now we just need to do a little bit of sorting out here. And we get minus 77 over 2 is equal to b. Sorry, let's actually put minus 11 over 2b. And then this gives me that b equals 7. Now, this is part of what we need to do next. So what we've done is we've essentially shown that these two lines intersect when b equals 7. Okay? So if they intersect when b equals 7, then we've now got to go about saying, well, about why they don't intersect. So this is now how we go about getting our final marks. So lines L1 and L2 intersect when b equals 7. Therefore, do not intersect when b does not equal 7. Lines are not parallel. Therefore, lines are skew. Just rewrite that word there, it's not very clear, is it? Skew. And that's essentially it. Now, if you want to know, like, if you might say, well, how are they not parallel? Remember that this is the directional part of the equation. It works like this, that's the position vector and that's the direction. So think of it like this. That's, although it's not exact, okay, and I'll explain in a moment, but think of it like this is a point, say a starting point, and then it goes off in this direction, okay? Not technically true because the line goes in both directions, but think of it like that, starting point, direction, yeah, starting point, direction. If the directions are the same, they're parallel. Okay, and for them to be the same, they need to be like a factor of each other, so or multiple of each other, I should say. So like 2 and 4, this would be minus 1, so this would have to be minus 2. And if this is 5, this would have to be 10 for them to then be parallel. Just pop it back up so you can see the writing there. Also, it's worth noting that this reason, parallel, you didn't need to say why, you didn't need to prove that they're not parallel. I mean, you could say it from the actual equations, but you didn't need to. So hopefully you've learned something new here, especially this word skew. If you see it in your exam and you didn't know before, you now know what it is. Because I think most people who did this could certainly solve these two equations and get lambda and mu. A lot went on and got b equals 7. From there, they had no idea. Okay, so quite a lot had the 3 marks, some more had 4, very few got above 4 marks in this one.